x equals a implies that f of x is continuous at x equals a. On the other hand, we will see that continuity at x equals a does not imply that f of x is differentiable there. A function f of x is continuous at x equals a if three conditions are satisfied. F of a exists and is a finite number. The limit of f of x as x approaches a exists, and the limit of f of x as x approaches a equals f of a. Now, the limit of f of x as x approaches a equals f of a implies that the limit of f of x minus f of a as x approaches a equals 0. Differentiability at x equals a implies that the limit of f of x minus f of a over x minus a as x approaches a exists. Since the denominator goes to 0, in order for the fraction f of x minus f of a over x minus a to have a finite limit, the numerator must also go to 0. That is, the limit of f of x minus f of a over x minus a as x approaches a equals 0. The limit of f of x minus f of a over x minus a as x approaches a equals 0 implies that f of x is continuous at x equals a. So, differentiability at x equals a implies that f of x is continuous at x equals a. Warning! If f of x is continuous at x equals a, the derivative at a might not exist. Consider the graph of the world-famous absolute value function y equals f of x equals the absolute value of x. It is continuous at x equals 0, but has no tangent there, so it is not differentiable there. In fact, the graph of this function looks like a capital letter V. The origin is the vertex of the V. The slope of the line of the graph in quadrant 1 is 1. While the slope of the line of the graph in quadrant 2 is negative 1, so there is no derivative at the origin. So continuity at x equals a does not imply differentiability there.